In plant wellness, we have a technique to intentionally ask the hard questions in the design phase. So while the design is still at a drawing level, we actually say, well, look, here's the machine, here's the layout, here's the assembly drawing. What if that part fails? What's the cost of this bearing failure in the future? And we can price the cost of failure. If that bearing fails, this shaft gets damaged, I've got to buy this from Europe, it's going to cost this much to get across. We can put a cost of the consequence of failure together pretty quickly. Once we know the cost of failure, the question then becomes how often can we afford that cost? So we go in and say, well, is the cost of a failure acceptable? If the cost of a failure is acceptable, then fine. It's only going to cost $10,000 to fix. Hang on, is that direct maintenance cost or total business-wide cost? Oh, that was direct maintenance cost. So the total business-wide cost to be $100,000 based upon the knock-on effect of a breakdown. Can we put $100,000 each time this particular part breaks? No. Okay, so now we know one failure is actually going to be too expensive. So if that one failure is too expensive, I go back to my design process and look at minimising the risks that lead to those failures. Can I design better machine, better material choice, different way of running a process? You know, these are the questions we have to ask while it's a drawing on the table. Because when I've bought the machine, then I'm going to live with that. Then I'm stuck with a dog forevermore. Now, if the cost of failure is acceptable and one breakdown, so we can live with that. Well, how many breakdowns a year would you be willing to live with? Can you have one a year, two a year, or one every 10 years that you can afford? So now we answer the two questions. Can I afford the cost, and how often can I afford that cost? Because if that frequency is too often, we go back the same way again. Back through and optimise our design selection to maximise the profitability in future. If I've got to spend 10% more to buy a better machine that gives me 5 times less breakdowns, and the frequency of failure now is far, far less, for 10% more capital cost, I've got a business case. I can argue with the manager and say, look, you want to save $10,000? Well, it's going to cost you 4 more breakdowns. Those breakdowns are $100,000 a piece, $400,000 here, $10,000 more there. What are you going to do, Mr. Manager? What do you think we should do? So as a business case, dollars in the bank, now I can sit down face to face and say, look, I think you're wrong. You better be careful. This is where we're going to go if these situations arise. Out of this whole process, while it's a piece of paper on a table, I come up with my project decisions that are going to maximise my profit and my operating maintenance requirements that will sustain the longevity and reliability of that equipment. And all done before I even go out and lay the purchase order. Now, out of all this will be possibly extra capital cost required, but it's traded off by the additional profit I'm going to make in future. Now, will the future be as I expect today? I don't know. Now, 20 years' time, will it be what I think is going to be today? I have no idea. But today, right now, knowing what I do know, knowing how we run the business and our plant, here's the best choice we can make from what we understand now. And so I call it an optimisation loop. We're not going to have no failures. We're going to minimise the cost of our choices to the least operating cost possible. And that'll be easily done with a couple of spreadsheets and some flow diagrams and a team of guys together looking at things in the point of view, how do I maximise my operating profits in future?